Even if it is 2023 and we have access to a lot of great software tools, we are still struggling with the basics. The best way to exchange data between front-end clients and back-end services is a debate still not settled yet, and in this video we'll take a look at tRPC, a possible alternative to your REST and GraphQL APIs. In short, today's context is perfect for a tool such as tRPC to emerge. On one hand, we have TypeScript being more popular than ever. The benefits of TypeScript should be known by now, and based on what I'm seeing, I doubt we will get back to the days of writing vanilla JavaScript anytime soon. On the other hand, the front-end tools finally reached the maturity level that allows their involvement in back-end work as well. Meta frameworks such as Next.js or SvelteKit are really trendy these days, and for good reason. They allow developers to finally write professional full-stack apps with the help of isomorphic code. So, tRPC builds on top of this and enables you to seamlessly exchange data in full-stack applications. Before seeing it in action, let's quickly review some of the benefits of tRPC I find really appealing. In their documentation, they outline the following. Automatic type safety. Since some of the TypeScript code is shared between the client and the server, it is easy to catch any errors in the client if changes happen on the server. Auto-completion. For the exact same reason, TypeScript is leveraged and tRPC can easily suggest all the existing endpoints you can use on your client. Light bundle size. The library has zero dependencies and a tiny client-side footprint. This is extremely important these days, where new approaches are pushing forward the idea of HTML-first apps with little JavaScript sent over the wire. Framework agnostic. As we'll see in a second, tRPC reliably runs in any type of JavaScript framework or runtime. It all sounds good on paper, but we should also discuss the alternatives. As a quick side note, back in my early days as a Java developer, I ended up in a project where they were heavily using a library called Java Direct Web Remoting. This was aiming to solve the same issues tRPC tries to solve today, bridge the gap between the server and the client. Some would argue that direct web remoting had a way harder task to accomplish since the backend was written in Java and we weren't enjoying the benefits of type safety on the front end. Long story short, due to maintainability and scalability issues, we moved away from DWR to plain, boring REST APIs. So the concept of remote procedure calling is far from being a novel idea, and it actually dates back to the late 1960s when the idea of distributed computing first came into the scene. Going back to the Java example, they had a remote method invocation API for a very long time, and they switched to a different technique called remote procedure call, which should sound familiar, back in 2017. So RPC was attempted numerous times before, and it has specific use cases where it excels at. In the next few minutes, we'll try to figure out if in 2023, RPC can also be reliably used as a communication protocol between a browser and a server, especially since established solutions such as REST or GraphQL already proved to be very efficient. Okay, it's time now to write some code. We'll use Node.js version 18 and of course TypeScript to get things started. FYI, I'm relying heavily on this nice little tool called Node Version Manager, or in short NVM, to switch between node versions. If you are working on multiple projects, and some of them rely on legacy code or older node versions, seamlessly switching between them is very convenient. Back to the code, I'll install the tRPC client and the tRPC server packages, and then I'm going to create two separate files, one for the server and one for the client. We'll work on the most basic setup and run all our code in the terminal. As I mentioned earlier, this code can then be easily migrated to any type of JavaScript framework. We'll see in a minute how your Next.js dev experience can be improved when employing tRPC techniques. Back to our code, let's create our server implementation first. I'll start by creating a tRPC instance and then I'll define some routes. If you are familiar with building backend APIs, you probably know that things can get easily out of hand. This is why it is always a good idea to organize your endpoints, or in our case, procedures based on the entities they are going to affect. So, in a movie router, I'm defining a procedure called findById. We are expecting a single string as an input, and if the input passes the validation, we'll query our database for the movie associated with that ID. Create, read, update, and delete are the usual operations you can perform on your data. We've seen how to read in the findById procedure, so let's work on mutating some data next. I'm defining a create procedure, which accepts an object with a name and a score as input. In all my videos, I'm usually mentioning the importance of always validating user input on the server, but I'm never doing it in my examples because it is usually a bit more involved. This is not the case in tRPC, which leverages ZOD, a TypeScript-first declaration and validation library. Zod itself is pretty powerful, and I advise you to check it out when you get a chance. It allows you to do various useful validations, so in our case, I'll make sure that the past user score is always a positive number smaller than 6. Then we'll do a mutation where this new movie is added to the database. Note that tRPC code behaves as any other backend environment, so you can work with other third-party APIs or various databases vendors to achieve your goals. In my case, I'm simply storing all this information in memory in a movie service file. Okay, so we have the router in place, and there are 2 more things we need to do before working on our client code. First of all, we need to export the router as a type. This is important and allows our client code to understand what endpoints are exposed and can be consumed. Second of all, tRPC still works over the HTTP protocol, so our routes need to live on an HTTP server. We'll create an Express app, link our router to the tRPC path, and then, finally, start our app on a custom port. So remember that, despite the fact we'll be making calls through an SDK, all data is still exchanged via HTTP requests and responses, but only one path called tRPC is going to be used. Now let's jump into the client.ts file and create a tRPC proxy client pointing to our Express app URL. Then, in our main function, we can create new movies by calling tRPC client movie route create procedure with the mutate action. Note that, as promised, tRPC is leveraging types and we have access to code suggestions exposing the entire list of procedures we can call. We can also easily test the Zod validations by sending a score of 7 to the server, and an error will be thrown as expected. This might not look like much, but it really simplifies the whole development process. For a good reason, the first thing tRPC advertises when visiting their page is the move fast and break nothing promise. A seamless integration between a TypeScript-based client and the REST API on the backend can be achieved as well, but with a lot more effort. You would need, for instance, to document your API using the OpenAPI standard, and then use a code generator which outputs a JavaScript client associated with your endpoints. Clearly, tRPC offers a way nicer dev experience, but I'm curious to find out if you believe this convenience is worth tightly coupling your code and locking your project into a specific library. In all fairness, the dev experience is indeed nicer. This is way more obvious when you are integrating tRPC with a framework such as Next.js. If you are not familiar with it, Next allows you to not only create client routes, but also API routes based on a file system router. This is pretty powerful, but can easily get out of hand, and your files and nested folders can grow exponentially while your API is getting more complex. Once you add tRPC in your project, all the nested API routes can be removed, and a single tRPC.ts file is enough to act as an entry point for your entire project. tRPC offers pretty much all the necessary features you would expect in order to reliably build your backend services. It offers logging, output validation, error handling, and more. Before wrapping things up though, I'd like to briefly look at one of the most important topics in any client-server communication protocol: authentication and authorization. Also, I would like to take a moment to ask you to subscribe to this channel if you want to stay up to date with dev topics such as this one. To implement authorization, we'll first need to create a context, which is an object holding various data needed in your procedures. In the createContext method, which will be called for each incoming request, we'll check for a JWT token authorization header, and if the data is valid, we'll add this user in the context. Then, in any of our procedures, we can check for the user in the context and perform our business logic accordingly. So these are the basics of tRPC. Clearly, there is a lot of potential here, and the interest around the project is living proof for that. To me, it feels like a great tool to use in small projects and prototypes, but based on my past experiences, I'm not sure it will scale up with larger teams and more complex projects. If you've made it this far, please help me fight the YouTube algorithm by liking this video. Until next time, thank you for watching.